Hello everyone, this is Guoping from SAP. Today I'm joined by my colleague, Swee, Bruce, and Raman. We're going to talk about how to build a great offline app. So what's the pinpoint and how our SAP products, mobile service, and Android SDK can help you with that. So while Swee and I am talking, my colleague Bruce and Raman will also help trying to help answer some questions for you. Okay. So before we get into technical details, let's first take a look at a use case. So imagine I'm a service technician and I need to serve aircraft that is kept at a remote location. So I will need to refer to user manuals and also the tasks assigned to me throughout my day. But if I have to browse these information online, then if there's a network outage, then I'm stuck. But if I have an offline app and I'm able to download everything I need at the beginning of my shift, and later throughout the day, I can refer to them locally, then even there is a network outage, I'm still okay. So that means a great deal to my productivity. But in some mission critical scenarios, the offline capability is not just a nice to have feature, it would be a mandatory feature. So let's regarding building an offline app, I think it's more or less like this iceberg. So people is only looking at the things above the water, which is the functional requirements. But the real effort is spent the things under the water, which is the offline capabilities, and but it's not that obvious to see. So why building offline could be complex? There are several aspects. The first aspect is about the performance. So a truly offline app, you need to download everything you need from the server to your local device. Then you need to think of how you can efficiently download them. And next time, when you already have the old data, you just want to download the new data from the backend again. So you need to think how you can download this delta information. And of course, because there's a lot of data on your local device, you might need to think of how you can efficiently query them and how you can efficiently update them. And another aspect is about supporting complex operations. So as long as you begin to support the local update, and when you update the local record, you will soon get two states. One is the server state, and the other is the local state. You need to think of how you can merge them, how you can present them to your end users. And also there's another complexity is usually the backend, when you create something in the backend will give you the primary key. But when you create something locally, you don't have the primary key right now. And then if you create another record that you need to link to the previous record using kind of the foreign key constraint, then you need to think of a way how you can do that because you don't have the real primary key yet. So there's also some complexities that to support the local update you need to think of. And the next thing you need to think about the resilience. So enterprise app has to be resilient. So there's a lot of ways an offline app could fail. It's like your download could fail, your upload could fail. But no matter how you feel, you should maintain the data integrity. So in no circumstances should you present partial data to your user. And also in no circumstances should you update the backend wrongly, like create a duplicate record on your backend. So this is also the things you need to consider. And of course, a great offline app, you need to consider all these aspects. So it could be a lot more than just an online app. So in this picture, I just want to give you an overview of the SAP Cloud Platform mobile service. From here, we can see mobile service has a lot of useful features, a lot of useful services. But today, we will just focus on these two parts, SAP Cloud Platform SDK and offline data server component. So this is the two components used with the offline. So let's take a look at the overall architecture from very, very high level point of view. So in the middle is a mobile service, and the mobile service is a PaaS service. It can talk to the OData producer or it's OData backend. It's in the OData protocol. We'll talk about OData in the next few slides. So then mobile service is able to convert the OData into a database and send it to the device. On the device side, our Android SDK can expose this data again in OData. So in this case, for your application, for the native application, you can just talk with our SDK using the OData protocol. So it's just like you are talking directly with the OData backend. So mobile service and Android SDK has taken care of the complexities of the offline. Okay, and so let's take a look at the OData. And the OData, in a simple words, is just an open protocol that allows you to expose your data, your model in RESTful APIs. So you can see a lot of vendors began to use OData and expose their services, their applications in OData. And here's an example of the OData metadata. So OData has a metadata to describe its underlying model. So in this example, we have an entity called the product, and it has keys, and it has a branch of the properties, and it also have a couple of navigation properties. It might looks a bit complex at the first look, but in reality, you do not need to write this metadata yourself. There's a lot of commercial tools and non-commercial tools, and you can use Node.js, you can use Java, so you can use a lot of tools to build OData. And it's here is just a few examples of how you can query the OData. So imagine the service route is your root path of the service, and you can use the dollar metadata to query the metadata. You can product here is an entity we have been talking about before, and you can use the product. This is the entity set. You can use this kind of URL to get all the product entities. You can use this kind of URL to get a single products, and you can use this kind of URL to get single products related navigation properties. So this 101 is the primary key. And here is also another example. You can run an arbitrary query to query your OData. You can use a filter. You can use a filter and a filter by an attribute of the of your entity. So it's very straightforward. It's simple but very powerful. And here's an example of how you can create, update, or delete your OData backends. So in here, you can use a post. You can use a post and use the JSON. You can use a post and use JSON to create an entity. You can use a patch, also JSON to update an entity, and you can use delete an entity. So it's all HTTP standard protocol, and it's all RESTful. Yeah. So let's take a look at the offline OData, the SAP's offline technology. So the SAP offline OData is different from other available offline technologies. It has these aspects. So first is it's based on sync mechanism. So the sync is fundamentally different from cache. It means that the sync, when we're using sync, we can download everything we need from the server, and we can work locally. We can read locally, and we can update locally. It's not just a one-way protocol, and it's not just read only. And we can also upload my changes to your backend. So it's again, it's two-way protocol. Download, upload, and it's not just read only. You can read, update, delete. When you work the local data, it's just like you work on the. It's just like you talk to the backend directly. Yeah, you have full capabilities, and then it's the mobile service has a pretty complex SSO mechanisms allow you to talk to the existing backend. So you can talk to the existing backend using mobile service, and we are able to propagate your mobile service. We are able to propagate your device identities through mobile service to the backend. And also we offer a very simple to use API, the OData API. You can just write very, very little code for the offline aspect. So the majority of your code is just dealing with your business. It's just dealing your business logic. And also we offer this enterprise-grade encryption on device. So it's often it's a mandatory feature if you are working on an enterprise app. And also we are, it's all backed up by our Ultralight database, which has a lot of very good features, including the decent optimizer, and it can store as to 16 gigabytes of the data. So it's a very powerful device database. So then let's take a look at how we store the data on device. So on the Android device, we have two databases. One is the entity store, and the other is the request store. So the entity store, we store the metadata information and the entity tables, or the entity data, and the relationship information. Yes, and we also have if you do something, if you update something, we will store this information in a request queue, which is stored in the request tables in the request store. And we will also store some helper information like the key mappings we'll talk about later also in the request store. So here, let's take a look at the initial download. So how we download, how we build it and install for the first time. So for the first time, when the SDK connect to the server, the SDK would send some queries to the server. So the SDK want to query. So this query we also call it defining queries. For these queries, the mobile service will send the queries to the backend and get the data from the backend. And then mobile service will use some kind of OR mapping technology to build the local database. So each backend entity will map to an entity table in the database. So in this example, you can see we have two entities, and we'll build the two tables. It's a product table and a supplier table, and we have a bunch of attributes which match the backend property. And we have also a couple of attributes which is offline specific. We'll talk about them later. And we also have another table which is a relationship table that links two tables together because in this model we have the relationship between the products and the suppliers. Yeah. So this is the initial download. And then let's take a look at the subsequent download. So now, once you have done with the initial download, you have your initial data. And the next time when you sync with the server, you want the new data. The data changed since your last download. You do not want to download everything all over again. So in this case, we also call it the delta download because it's the delta information. And ideally, the backend, your backend should be able to do the delta calculation. Your backend to calculate what the information has changed since your last download. But if the backend cannot do that, the mobile service, the middleware layer can also do the job. But I would say it's a suboptimal. It's a fallback solution. But here I just want to give a quick overview of how mobile service is doing the job, so that even if you want to build your own backend to handle the delta, you can have some rough idea. So in this case, the mobile service, in order to compute the delta, the mobile service will need to store this information, the keys and the hashes. You need to store the keys and hashes on the cloud. And then mobile service would need to get the backend data. So the backend data for this device. Once the mobile service has these two sets of data, mobile service can do the calculation. So if there's the keys available on this device, and there's also the key, if the keys available in the backend and also the keys available on this device, then we know it. Then if the hashes is different, then we know it's an update. If the hashes is the same, then we do not need to do anything. But if the keys is available on the backend but are not available on the device, then we know it's new data. We send the insert into to the backend. The keys available does not available on the backend but available on the device, then we know we need to delete them because it has been deleted on the backend side. But this is some rough idea how we can build a backend that handles the delta information. But there's a shortcut. So if you want, you can also use this kind of mechanism like last modified timestamp. You can also use this approach to build your delta. I'll just give an example. So in this table, we have the keys, we have the attributes or the column, and you can add a timestamp column. The timestamp column is just every time you update this row, you update this timestamp column to the current timestamp. So in this case, if I want to query all the tasks sent to me, imagine it's the task table. If I want to query all tasks sent to me, I can use this query. Assign me equal to Guoping and the last modified timestamp less or equal to my last download timestamp. Then I can get all the changes since my last download. But it has two drawbacks. First is you need to add a logical delete column to track the delete. Otherwise, if you just delete them physically in your backend, the next time when I use this query, I will not be able to find the deleted data. So the entity the record might live on my local device forever. So that's one problem. And the other problem is like this. If someone has transferred the task from me to someone else, like to Swee, and then in this case, if I still use this query, I will not be able to find the record because the assignee has become to Swee, my colleague. And then in this case, this task might be left on my device forever. So that's a problem. That's last modified timestamp cannot handle. So in this case, you need to think of other approach. So this is just something you need to pay attention to when you build the delta checking yourself. And then next, let's take a look at how our Android SDK handles the local query and local update. So for the local query, our SDK is able to understand the old data. So this is the typical old data queries. You give the old data query to our SDK, and our Android SDK will convert it to the SQL using the old data parser. And we also take care of some of the offline specific aspect, and then we would use the kind of OR mapping way to deserialize this data from the database tables to POJO, and they hand over this POJO to your application so that you can work on it. So this is about the query. And for the update, it's like if you post something to our SDK, if it's in this case you are trying to create a product, and then we'll need to do two things. First, we'll need to create a local role in the entity table. So this role is used when you query your data, when you query the products. We'll use this information to give back to you. And next, we create another role in the request queue table. So this table is used to send the information, the requests, eventually to the backend. So we do these two things. And the one thing I would want you to pay attention to is for the key, for the local key. So in this example, when you only give the description and you give the category, but it does not include the primary key of your entity. In this case, we will create a local key. This local key you can think of as a placeholder. It will be replaced later by the real key. I'll talk about it in the next slide. So and then let's take a look at the update. So when update, we also create a request queue table when you do an update, but we also on the entity table we do this. We copy original row to a local row. So we copy the server row to the local row, and then we mark the active flag with the original server row to false and the local row to true. In this case, if you query our SDK, we will give back this local row. We'll give back this row, not the server row. And of course, we will also update the columns that you want to update. It's like in this example, you want to update the description column, so we update this column. And so here you see both the local row and the server row, they can change independently. So it's like you can update your local row. It's like you can issue another update again. And if you try to do a download, then the server the server role might change because someone else might update the same role as you did, and someone else, they may update another attribute, it's like the category attributes or something like that. But in this case, we will try to merge them. We will try to merge the local role and the server role and present to you so that you always have the latest information. Yeah, this is the local update. So once you have done the update locally, you will upload these to the server. And on the server side, we will get the request queue from your Android device. And in this case, this request queue, we have it's ordered. First, it's ordered, and then the request might depend on each other. So in this example, the request 4 depend on request 2 and the request 2 and request 1. So in this case, either request 1 and request 2 failed, the request 4 we will not send to the backend. We will just mark it failed. So this is the one thing to pay attention to. The other thing is about the key mapping. I have talked about it before. So imagine once you create a category entity on your backend, the backend might give you a real key. So you don't give you the real key locally. You don't give the real key locally, and when you submit this request to your backend, the backend gives you the real key. Now we have key mapping. We have the local key and the server key, or the real key. And it's the same when you do the product. You also have another mapping. It's the local key and the real key. And then when you want to link the product and the category together in the fourth request, we need to replace the local key of the product and replace the local key of the category with the real key of the product and the category. So this is what we're trying to do. So before we issue the request to the backend, we will replace any local key to the real key, so that the backend will never see the local key again. They just see the real key. And the same thing we'll do for the e-tag. So for the e-tag, it's like if you create anything on device, we'll assign it to a local e-tag. And if you do an update, we'll assign another local e-tag. But when we replay these informations to the backend, we will try to replace the local e-tag with the real e-tag step by step. It's the same like we do the replace for the key mappings. This is. And the next thing I want to talk about is about the error handling. So the error handling would be a little bit complex than the online app, because on the online app you will always get your response immediately once you issue a request. But for the offline, you only get the field request after you do the upload. So in this case, we offered a special entity. We call it the error archive entity. It stores all the field requests and response. And we offer 3 ways to fix them. So first is you can do the canceling. You can cancel a request using our SDK. It's just like you cancel. It's just like the request does not happen. And you can issue another update to update the field entity. It's like you create an entity, but it's field on your backend, and you issue another update. And in this case, our SDK will merge the create request and the update request into another create request. And when the SDK upload this to the server will replay this new create request again. And of course, we have more advanced usage. It's like the fix request directly. You can also use. And the next thing I want to talk about is about concurrency. I just want to say is our SDK has to do as much as we can to maximize the concurrency. You can do a lot of things while you download. You can read while you download, you can read while you upload, and you can upload while you download, and update while you upload. But we will maintain the data integrity. It's like when you read while you download, we will never present partial data to you. We'll never present the parent without child or child without parent. You either see all the new data or you see none of them. This is what we guarantee, and this also will guarantee that when you update, when you upload, you will never do harm to the local database. It might be this update will be uploaded for the next time because of race condition, but you will never do harm to the local database. Okay, I think I have finished all the stuff on my side, and with that, I will hand over to my colleague Swee. She will help present some advanced stuff and also have a live demo. Yeah. Okay.
Yeah. Thanks, Guoping. So I will share my screen first. Sorry. So till now, you should already have one idea. So what offline data's main functionality is, and what can help you to achieve seamless offline capability for your business. I will take the last couple of minutes to step further with you for what's under the water of the iceberg. So let's first say a normal scenario, that unstable network, or there is any possible interruption during the data upload. If this happens, and also it's just in the middle of your data upload, so in such case, what the client can do? So the client doesn't know whether it was sent to the backend, or just the response was lost, or it never made it to the backend. As a result, the client have to resend it. So for some requests, especially for the post requests, issue them more than once, it will lead to data inconsistency or duplicate key exception. To make the app developers' life easier, so we use repeatable requests to resolve such ambiguous. The data producer or backend is the place that has the exact knowledge, but we cannot assume that the backend always supports it. So, and actually most of them doesn't support it. Then in this case, the most reliable place is the middle layer, the server, the mobile services. So which have the knowledge and will.
Oh, hello, this is Jana. We can't see your presentation, unfortunately. You need to share your screen.
Okay, so I think I already shared. Let me check. Sorry. Didn't share. Okay. Okay, now you can see, right?
No, still not.
Still not?
No.
Okay.
Can you find the button, share screen?
Yeah, I already clicked that. Okay, so now here you go.
Brilliant, thank you. We can see your presentation now.
Okay, sorry.
You should go presenting mode.
Okay,
yeah,
so
good.
Let's continue.
Yes,
then,
please.
Yeah. So in the middle layer can have the knowledge, then can handle this. This is we call it repeatable requests. So by using this technology from this Android SDK, so from the app developers, you can get free of this concerning and just leave it to SAP SDK itself. Then let's talk to another scenario. So imagine when you bring a device and open some transactional and operate on some your business transactional data. It should be normal that you will have some back and forth changes. For example, first change some record and then change the same record again and then change it back and so on. Or you create some data, but during the day operation, finally it should delete it. So it will lead to quite a few requests that actually out of date from the data result point of view. So this is the way how we use a mechanism request optimization to handle this situation more effectively. So for example, if there is many requests there is a post or there is a patch that it can be consolidated to a post in the end, or there is a patch then can be consolidated to patch, or there is a post patch delete, it can be eliminated entirely at the last. I will give some example in the following slides. So this is not only just affect the network traffic. Just think, if there's all this requests reach to the backend, then if we don't do this optimization, the backend needs to do this from the first to the end. That means they need to insert some data, search some data, and then change some data and delete some data. All this can be saved with this request queue optimization. This is just a straightforward scenario, but actually it's not as it sounds, as simple as it sounds, because for your business data, it can be all kinds of data model. So there will be many different kinds of relationships. So with these different relationships, then the request queue optimization can handle it properly to know what exactly should be combined or should be merged with this functionality. And also there are some cases there is cannot be merged. So in this way, also give this the SDK also gives a chance to mark this request as non-mergeable. Then the request to optimization will don't merge that. Just to give you an example. So if you have a workflow and you have in the workflow you have the status field, each you should for that you can mark it as non-mergeable, because the status, even you repeatedly change the status field, but actually this status is count. It's just mean the last status, but it's all the status along the way. So this is the flexibility to allow the SDK developers, the app developers can use this request optimization according to your business needs. Then let's come to example. So this is first example, as we mentioned, when you create a customer in the beginning, and then with the given name Joe and the surname Smith. And later, you need to patch this customer request. You change this surname as Mike. So after the merge functionality, so all these requests will be merged to one. As a create customer, and with the given name as Joe and the server name as Mike, the up-to-date one. So this is one example regarding the post and the patch, and then we combined to a post with the latest data. Then let's say another example. So if we have the following request, you create an order, and then you update this order, and then you relate this order to the customer, and then finally you found that you should delete this customer. After the merge functionality, our request optimization algorithm running, then all these requests will be combined into one. This is delete customer. So why this come to delete this customer is also depends on how your metadata is designed. So in this case, we assume the metadata is that the order will only exist with a customer. So if your customer is deleted, that's for sure that your order will be deleted in the end. So with this optimization, as I mentioned at the beginning, it's not just reduce your network traffic. It also save quite a few time in the backend. So that's the benefit that by using this SDK you can achieve for your offline application. Then at the last, then let's take a demo, a small offline style demo. Just take 5 seconds to recap the process. So when you do an offline app, you first will open the store, the offline store. Then during the install, you will do initial downloading. Download your business data to your local device. Then once the store is set up on your device, you can do any query that your business data supported. And then you can do update the data, and then you can do the upload download once it gets online again. Then let me give you small demo here. So this is offline style app. So you can easily use follow our wizard guide to build this offline app by yourself. So then first we will log on. Just as we always do. And then you will first initial the offline store and then download all the business data to your local device. It will take some time because this is all your data, all your business data download to your local device. So you can define your offline data, what it will be, what it should be. So this is highly configurable. Then you can, then the store is set and open in your local device. Then you can do query as you can see the items, the details, and then you can change some fields. And then you can update on your device. So you can do the synchronization as you're still online. So after the sync, the latest data will your latest request will upload to the backend, and the latest data will also download it to your local device. Then let's switch off the Wi-Fi to imitate that the offline scenario. And now the Wi-Fi is switched off, but you still can do, say you cannot do sync because you are not, you're offline. And then you still can operate your offline store as normal, do the query, do update, to do any operation you need for a business. And then once you switch on your Wi-Fi, and you can do a sync. Then you choose the sync. You can see the latest update on your device is sent to the backend, and at the same time, you also can get the updated data back to your device. Okay. So this is a demo that I want to show today. It's just a very straightforward the offline style scenario. Then with this simple SDK, by using this Android SDK with the offline functionality, then you can build a great offline app for your business. So we put some very useful results here. You can go to the documentation store to see all the help and the development guide or any overview or more deep information for the offline OData store. And also you can, in the tutorials, you will find a wizard, the Android wizard, to help you set up Android app just as I showed. And there is the API reference. Then you can go there to see what kind of API that we could provide, and you can build upon that for your application. And also there is a link for how you what's for the HANA cloud platforms account you can use, and you can directly go to the link to have a check. And there's also, we have another roundtable session for our Android SDK. So you are highly welcome to join, and we can have more deep discussion there. Okay, then hand over to the host, maybe. Thank you.
So how does the application handle? So I would like to take a shot at the first question. So it's this in at least in our performance testing or in our benchmark, we have the partners is using this kind of like 1,400,000 records. So I think it's to handle this large amount of records. First, we need to, of course, we need to be able to download them efficiently, and then on the local side, we need to have a proper index. This is the first thing. If you want to query in this field, and then you need to have a proper index built on this field. So this is how we are handling that. So far we haven't been see a real customer use case that have been using such a million records, but we at least in some partners are preparing to use such a kind of large data sets. So yes, we haven't been see provoking issues so far. No. Are there any others?
Okay, so maybe for the second question, so are there scenarios where the actions performed by me in offline mode can be lost if someone else has modified the records I modified? First of all, for the actions performed by you in the offline mode, normally it cannot lost. It's in your device. And then later when you're online, you will send your changes, the local changes to the backend. But if somehow it's got lost, and then that means that is just like you don't do this operation on your device. So if others modify the same records from their device and they successfully uploaded it to the server, to the backend, the next time when you do a sync, you will get this data back, the latest up-to-date data back to your device. So you will get the latest data.
Okay, so I want to add some comments about that question. So I think it also have some implications that how we handle the conflict. So it's like I update the record locally, and you also update the same record locally. If we do nothing on both sides, then in the end, it's like the last right win. It's like this. It's also possible that your update just override by someone else if someone else comes later. And we also support the other scenario. This resolving this conflict is using the E-tag. So it's like when you update something, you give the E-tag of the current state. When I update something, I also give an E-tag of this current state. So when you update go to the backend state has become, you have updated your backend, and the backend state has become another E-tag. So when the later request comes, this request the E-tag will not match. So it will not match. In this case, it's the second request, the second update will fail. Okay, so in terms of the in terms of conflict resolution, basically you have the two ways. One is you just ask right win, which normally also works for scenarios in many cases. And also you can use the E-tag. In this case, you can prevent the conflict. It's kind of like the first update wins. So it depends. You can choose what the best fit for you. But yes, but like we mentioned, we will never lose an update. They will eventually go to your backend. No matter you do, it will go to your backend. You either your update succeed on the backend, or you receive an error response and it will appear in the error archive and go back to your device. Yeah. Okay. Which approach is recommended to update or long holding?
Yeah, the offline style is using the sync mechanism. So once you want to do a sync from the app, so we have the API, and then you can do the sync. So we don't normally do the polling or periodical mechanism here. Guoping, any comments you want to add?
Yeah, no, that's good. Yeah.
Okay, then thank you all for your interest. So if any more questions, Just welcome to the roundtable session 1 hour later.